Hi everyone and welcome back to my channel. I'm Anish and today we'll discuss a question on computer organization and architecture from the part 1 of this series. Few students texted me that they had a bit of doubt on this question, like the explanation was not as much clear. Okay, so I thought of giving it a second explanation. Like one student texted me like you could have explained like this, so I thought why not make a video out of this. Although there also I think it has been explained, but here I will explain it in a more elaborate way. Okay, but the method that you will follow, right, you will follow that explanation only, because in examination hall you don't have infinite amount of time to break down a problem for 30 minutes, right? Here we have, because I am teaching you, you need to learn, this is a new thing, that's why. But in examination hall you will solve how you solve in the lecture. Okay, so like this was the question. Basically we had a loop, we had few instructions that had the loop. Okay, and they are telling me that they have given me few initial conditions, that memory location 3000 has content 10 and the content of register R3 is 2000. So memory location 3000 has content 10. Okay, so these things are written over here. I will do one thing, I will just take this, copy and paste. So the information that is given, I will write that memory location 3000 has value 10. So this is the memory location 3000 that has a value 10. Also they have told me that the register R3 has 2000. So R3 register, like I have few registers, one of them is R3 actually, R3 that has a value 2000. Okay, and also they have told me from 2000 to 2010 the content of memory location 2000 to 2010 is 100. That I have already drawn. Okay, that will come to later on. And the program is loaded from the memory location 1000. So what does it mean? It means if it is loaded from the memory location 1000, that means my current PC value, that is program counter value, will be 1000, right? Because PC stores the next instruction. So after this instruction has been fetched, then PC will get updated simply. Okay, so that is what they have given me, nothing else. Okay, R2 R3 are also there, R2 and R3 are also there. They have not given any information about R2 and R1. Okay, they have not given that information. Okay, first question was, assume that the memory is word addressable. I hope you know what is word addressable. If you don't know, then you haven't watched the lecture 1. You have to, not the lecture 1, basically part 1 of COA. So you have to watch the part 1 of COA. Then the number of memory references for accessing the data in execution the program completely. So this first part was very simple. How many times will I access the memory if I run this program, right? So I observe there is a loop here. And where does this loop end? This loop ends here, right? So we will loop. How many times will we loop? That I have to figure out. How many times will we loop. Okay, so that is one thing. And another thing is, in this whole loop, how many times am I accessing the memory? Okay, so if I start from the line 1, that is instruction I1. Okay, let me name this instruction I1, I2, I3. Okay, all these are names. So if I start from instruction I1, I see I am moving from memory location 3000, the content whatever is stored in memory location 3000, to register R1. So I'm going to this location 3000 and storing this value in R1. So I had to access the memory. This is not a register, this is not a general purpose register, right? I have to access the memory. So for this particular instruction, I had to access the memory once. Okay, let's come to the next instructions. So this is the next instruction where there is a instruction that is move R3 R2. What does it do? It is not exactly that move the contents of R3 in R2. No, it tells that it is like indirect addressing mode. What it tells me, that in the content of register R3 there will be address. That address is the address of operand. So on that address, okay, on R3 I have 2000. So I will go to this 2000 memory location and copy the contents 100 into register R2. Correct, into register R2. So did I need to access the memory here? Yes, right? First I access register R3, that is fine. We don't need any memory access. But as soon as I got this value 2000, this is what? This is the address of memory. So I need to go to this memory location, then access the memory 2000 and then store it. So I had to access the memory, right? So again, here also I had to access the memory once. Okay, After this, I'm seeing it is doing addition operation. Then again, here is a move operation, right? If this is doing move operation, that means again, what it tells me that the contents of R2 is stored in the memory location present in R3. So R3 had what? R3 had this value, right? So I will go to this memory location and store the contents of R2. So something has been happened at R2, I don't care, but I have to access the memory. That is the most important part, because I want to solve this 71 question. Okay, I will come to the other parts later on, but first of all I want to solve the 71 question. So here again I had to access the memory. From the mnemonics as well, I can see that there is a MR3, there is a MR3. That means these mnemonic means I'm accessing the memory. So obviously this also will be a memory access. Okay, now here am I accessing the memory? No, this is just simple increment, this is a simple decrement, and then I am finishing my loop and then again restarting. Okay, so that is point 1. So I am accessing the memory outside loop once. This is outside loop once. Okay, and inside loop, how many times am I accessing the memory? Twice. Inside the loop, I'm accessing the memory twice. So if I find out how many times this loop runs, so let's assume that loop runs for n times. If loop runs for n times, then total number of memory access, mem access, will be equals to 2n plus 1. Why 1? 1 is due to the access during the first time this instruction ran, right? This was not inside the loop, that's why this 1 came. And why 2 times n? Because for each time I'm running the loop, I am accessing the memory twice. So if I run the loop n times, then I will access the memory 2 times n, right? That's why 2n. Now what task is left? I have to just find out this n value. If I find out this n value, then I will be able to understand that how many times I am accessing the memory. So how to find out n? So for that, right, we have to go into the program. Okay, we have to go into the program and understand what each instruction is doing. So here what I'm doing is first moving the content that is present in memory location pointed by R3 to R2. So R3 has 2000. I go to this memory location 100 and then I place this in R2. Correct? That is what it is doing. It is placing this in R2. So simply this 100 will come here. Okay. Then what I am doing, I am adding. Okay, before that, right, I stored the memory location content of 3000 in R1. So what is present in 3000? 10, right? So I will store this in R1. So this also I did beforehand. This will come here. Okay, so this is 10. Now next what they are doing here in the third instruction is adding R2 and R1 and storing it in R2. So what I am doing is I am adding R1 and R2 and storing it in R2. So now my R2 becomes 110 basically, right? R1 is still 10 only. R1 doesn't change, but my R2 is 110. Next, what is happening? Next, I am storing this R2 value, right, in memory location pointed by R3. So R3 has 2000. So I go and update this value now. This value gets updated. Okay, to what? Whatever value was present in R2. R2 has currently 110. So this will be updated to 110. Next, I increment my R3. So R3 has value 2000. Okay, R3 has value 2000. So it will be incremented to 2001. It will be incremented to 2001. Okay, because previously R3 was 2000. Now it has incremented to 2001. So from here I come here. Okay, from here I come here. Next I am decrementing my R1 by 1. So R1 will be decremented by 1. So R1 will now be decremented by 1. So R1 will become 9. Now what they are checking me? branch on not 0. Okay, so here, right, they should have actually like what this means. This means branch not 0. It checks the 0 flag. So there is a flag in the CPU that checks the previous arithmetic operation that we did, was it 0 or not. If it was 0, the 0 flag, there is a bit for the 0 flag, so there is a bit for the 0 flag, right? Okay, this is 0 flag. I hope you have studied the program status word, all those things I have taught. Okay, if you haven't already, please see the part 1, or it may be taught in the part 2, in either of them. Okay, so there is a flag which is known as 0 bit. Okay, what it stores is, it stores the previous arithmetic operation that the ALU performed, was it 0 or not. If the previous arithmetic operation which the ALU performed is 0, then this bit will be set, that is this bit will be on. If the previous arithmetic operation which the ALU performed is not 0, then this bit will be 0, not set. Okay, that's the information that the 0 bit gives. So this instruction, okay, don't worry, nowadays if some question will come, they will explain all this, right? Don't worry about this. But previously it was like you were supposed to know all this. Now they will give the information. Okay, so here they are telling me branch not 0. So what this instruction does is it goes to the 0 bit. Okay, CPU knows the address of this 0 bit. It goes to it and checks whether this bit is set or not. So if this bit is set, it will if this bit is not set, not 0, then it will loop again, start from here, right? If this bit is 1, then this loop will stop. Okay, and it will not go to this branch, and it will just halt its execution. Okay, point 1. Now point 2 is, currently in the first iteration, is the 0 bit set or not? Tell me in the comments below, is the 0 bit set or not? So obviously if you have already understood that, what was the previous arithmetic operation? The previous arithmetic operation was R1 is decrementing by 1. If I decrement R1 by 1, what is the result? Result is 9. Is 9 0? 9 is not 0. So the 0 bit will not be set. It will be 0. And what is this telling me? Next instruction, it is telling me branch if not 0. So I will branch only if the 0 bit is not 0. So basically it is not set. So yes, it is not set. So I will branch to loop. I will again start from this loop. So this loop will keep on running. Okay, this loop will keep on running. Until when? Until the previous instruction results in a 0. Okay, when will it result in a 0? So first observation is, this operation on R1 is only happening once inside the loop. I am not doing anything with R1 anywhere else. So I don't need to worry about anything else. I can just observe this instruction. Okay, I will come to the next question later on. So how you would have solved if only this part came, right? Only this first question came. If these two parts didn't came, so you don't need to solve the whole question. Don't need to waste the whole time. Okay, so here I am observing that R1 at every step, what is happening? R1 is just decrementing by 1. So what will happen? At the first step, R1 decremented from 10 to 9. In the second step, R1 will decrement from 9 to 8. Third step, R1 will decrement from 8 to 7. So that is what will happen, right? So it will go from 10, 9, 8 and 7, so on. Okay, so how do I find out? Finally it will go to 0, and as soon as it goes to 0, right, as soon as it reaches 0, the next instruction will check branch if 0 or not. Then it will check, okay, the previous result was 0, so 0 bit is set now, so I will not branch anymore, I will halt my operation. So how do I know how many runs are this? So you can take always in these type of cases, right, always take a smaller example. So let's take an example. If we start from 3, if I start from 3, then I will go to 2, then I will go to 1, then I will go to 0. Okay, so how many times did the loop run? So when this was 3, obviously we run loop once, right? So here the loop ran once. Okay, 1, 2, 3, 4. So we ran 4 times, right? We ran 4 times. So the loop ran here 4 times. If this value would be 10, then how many times the loop will run? 10 times. Okay, so simple. My n, the loop will run 10 times, so n will be simply 10. So from here I can tell you how many memory access will there be throughout the whole execution of the program. That is 2 times 10 plus 1, 21 memory executions. Okay, so that's why answer for the first one will be D. So this was just the first question. Okay, so what about the next question? What about the next question? So next question is bit interesting. What they are asking is, they're asking, assume that the memory is word addressable. After execution of this program, the content of the memory location 2010 is. So what will be the content of the memory location 2010 after the execution of the whole program? Okay, so I have to find out that. So although I explained everything there in the previous lecture, but there was a bit of doubt that what will actually happen. So here I have broken down everything in each loop, right? What is actually happened. So how is R1 going in each loop, how is R2 is going in each loop, and how is R3 going in each loop. One of my students like sent this explanation in handwritten note, so I tried to explain the same similar way only. Okay, so I have already told you, right? Like I am running the loop for 10 times. My R1 is going from 10 to 9 to 8 to 7 to 6 to 5, like this, right? It is reducing. What is happening to R2 and R3? So R3, right? If I observe in this whole loop, I am doing some memory access with R3, but the value updation of register R3 is only happening here once. At every loop, I am incrementing R3 by 1. So my initial value of R3 was 2000. What will be the final value? First loop I ran, it will be 2001. Second loop, third loop, it will go on like this. At the end, finally my R3 value will be 2010. Okay. And what about R2? So R2 is a bit interesting, right? What is happening to R2? Every time R2 is getting updated to 100. Okay, because my memory location R3 has 100, right? Because not 100, sorry, memory location R3, yeah 100 only. So initially it was 2000, so I went to this memory location, this value initially at 100 that I stored in R2. So again in the second loop, what will do, this R3 will be incremented to 2001, correct? R3 will be incremented to 2001, as we can see from here, right? As we can see. Okay, so as R3 has been incremented to 2001, the starting of the loop, what it will do, it tells me go to the memory location pointed by R3 and store it in 2000 to store it in R2. So now R3 has 2001. So R3 now has 2001. So if R3 has 2001, I will go to this memory location 2001 and store this value in R2. So actually R2 had just before this, right? R2 just before this had 110 value, correct? From the previous loop. But as I again updated the value, it again reset it to 100. Okay, because I just update the value at the start of the loop. Again, what I performed, my R1 has been updated, right, to 9. Because here you can see in this loop diagram, R1 has been updated to 9. So R1 has been updated to 9. So now if I perform R1 plus R2, what will happen? It will be 109, not 110. And then what I am doing, I am simply just again storing this value in memory location R3, right? Again going back here only and then cancelling it and changing it to 109. Okay, so this value again gets changed to 109. So like this will go on, okay, this will happen. Each value R2 will each time will be 101, then again R2 will be stored with 100, then again I will update it with R2 plus R1, that is 109. Again I will go on like this, right? If I go on like this, at the 10th cycle what will happen? Many students told me that value of R2 will not change. Yes, you are correct, but they are not understanding this. They are not understanding that there will be value updation. Okay, my program will run, and what I will do, I will change 100 with 100. Okay, there will be some value updation. Memory values will be present in the bus. Values will flow, but as both values, initial and final values, are 100, that's why you are saying that there is no change, but there is change. Values are getting updated, but in this case my initial value, that is 100, and the final value both are same, that's why it became same only, but I am updating the value. Okay, the program is updating the value, but luckily my initial and final value are same, that's why it became 100 only. But what you have to understand is in the hardware view, right? In the hardware CPU, the data is flowing in the bus. Okay, 100 data is flowing in the bus, it is getting received by the data register. So all those things are happening. So that is the important point I wanted to explain, because few students have doubt on that. So yeah, this value will be 100 only, because at every loop I am decrementing by 1, and this value is getting updated in the memory location 2010. Because what will happening? So during the first loop, this got updated to 110. In the second loop, this will get updated to 109. Then in the third, 108, 107, 106, 107, 105, 104, 103, 102, 101, and 100. Okay. Yeah, it seems like it is not getting updated, but I am updating it with 100. Okay, I don't care about the previous value. I'm updating it with 100. Luckily, my previous and current value is same. Okay, so obviously this answer, right? This will be 100 only. This will be 100 only. Okay, and this, assume that the memory is byte addressable and word size is 32 bits. If an interrupt occurs during the execution of the instruction increment R3. Okay, an interrupt is occurring during the execution of increment R3, what return address will be pushed onto the stack? Okay, so it is byte addressable with the word size 32. So it is anyways byte addressable. I don't care about word size. So what will be the return address? Okay, so they are asking me what is the return address. So how do I find out the return address if it is a byte addressable? If it is byte addressable, so simply what you can do is, like, they have not told me that this actually, right, this is during the first loop cycle. This is during the first loop cycle. Okay, only this should have mentioned. This is a old question, that's why they didn't mention this. They're talking about when I'm executing the loop for the first time. So when executing the loop first time. Okay, so if I'm executing the loop first time, how many bytes, like what will be the value stored, pushed back into the stack? So when I face a interrupt, right, what happens is, as soon as I reach to this instruction, I face an interrupt. So what we do is, we store the value of where the instruction is stored. Okay, we store the address of the value where the instruction is stored. Then again, as the interrupt has been finished, then I come back, then I pop it back from the stack. This has been explained in my COA lectures, so I will not explain here. I will just statically solve. Okay, so they are telling me I am encountering a interrupt while executing this instruction, while the execution. So if I am executing this instruction, what is the current PC value? PC stores, program counter stores the next instruction. So PC value will point to the address of the next instruction, right? So what is the address of this? So if I have, let's say this is I1, this is I2, I3, I4, I5, I6 and I7. This is I6, right? Simply I6. Okay, so they're telling me it is byte addressable, and here, right, they have told me the instruction size as well. Okay, now in words, they have told me the instruction size in words. Okay, so I can compute the bytes, right, out of this. So a word size is 32. Word size is 32 bits. So how many bytes is this? One word is 4 bytes. One word. Okay. So all these have been explained in my full course, so I will not explain here. One word is 4 bytes. So how many bytes will be two words? It will be 8 bytes, right? 8 bytes. This will be 4 bytes. This will be 4 bytes. All this will be 4 bytes. Okay. So I will increment. I will just do the simple increment. So I have started from 1000 because they have told me initially I was starting from memory location 1000. Okay, the program has started from memory location 1000. So PC initial value was 1000. So 1000 PC final will be 1000 plus until this point, right? Until this point. Okay, what is the value of this address? So I have to add all these values, right? I have to add all these values. Okay, so what are these values? This is 4 byte, this is 8 byte, this is also 4 byte, correct? So this is 4 plus 4 plus 4 plus 4, that is 16 plus 8, that is 24 bytes. Okay, so this one will be 1024, right? Plus 24, this one will be 1024. Okay, This last question I solved in a hurry. If you want to have a bigger explanation, you can go back to my full course. There, I have given more explanation on this question. This is not that important. That's why I solved it in a hurry. But that's how you solve in a fast manner. Okay, so you should not take much time to solve this question in second time. First time you can do the breakdown. So I have broken down this here. You can see the breakdown and understand everything. But the most important part is first, as soon as you understand the thing, right, then you try to pick up an algorithm that solves the question in a faster manner. Okay, so yeah, that's it about this short question. A few students had doubt, so I tried to clear it. So I hope you enjoyed this video, and make sure to like the video. Make sure to watch the part 1 if you haven't already. Many students have watched it and loved it, and the part 2 is also after this. Make sure you watch that completely. Trust me, you will get full marks for your COA. I have taught you just like what they teach in CS branch, and even more than that. Why have I taught you like that? Because you never know how difficult GATE can ask questions, and in the future, right, I'm expecting that COA will, the syllabus of COA will increase for EC, because digital VLSI placements also require COA. So I think they will go into that domain more. So yeah, I hope you have enjoyed this series. Thank you for watching, and I will see you in the next lecture. Until then, happy learning.